In this lesson, we're going to learn the values of some of the angles that we're going to be working quite a bit with. The first two columns of this table that I want to fill out is going to be the 30 degree and the 60 degree angle, because that's going to come from your 30, 60, 90 triangle in which that we had learned about earlier. So this is going to be my 60 degree angle. And this is my 30 degree angle. Now, if you remember, the side opposite the 30 degree angle is going to be the shortest side, which is what we refer to as A. Now, I'm going to fill in the length of these sides by using A equal to 1. Now, if you use A equal 2 or A equal 3, it's all going to end up being the same in the end when it reduces down, but we'll just keep it simple to begin with and let A be equal to 1. So if this side is 1, if you're on the side that's opposite your 60 degree angle is A square root 3, so that would just be 1 square root 3. And the side opposite your right angle is 2A, so 2 times 1 would just be 2. Alright, so I'm going to come down and I'm going to fill in this column. Now this goes back to opposite, adjacent, and hypotenuse. Like sine is opposite over hypotenuse, cosine's adjacent over hypotenuse, and tangent's opposite over adjacent. So from the 30 degree angle, okay, so we're up here at the top from the 30 degree angle, your opposite would be 1, hypotenuse would be 2, so that value is going to be 1/2. Okay, then cosine of 30 degrees, that's adjacent over hypotenuse. So from the 30 degree adjacent, square root 3, hypotenuse is 2. And tangent is opposite over adjacent, so that would be 1 over square root 3. Okay, from the same triangle, from the 60 degree angle this time, sine would be opposite over hypotenuse, so that's going to be square root 3 over 2. Cosine is going to be adjacent over hypotenuse, so that would be 1 over 2. And then tangent is going to be opposite over adjacent, so square root 3 over 1 would just be square root 3. Next, I'm going to fill in the 45 degree column. That's going to come from the 45, 45, 90 triangle. Of course, each of these angles are 45 degrees. Alright, so of course this is isosceles. Since these two angles are 45, the two legs are the same length, and if you remember, that's what we refer to as A. So again, I'm just going to let A be equal to 1, so that would be 1 and 1, and then the hypotenuse is going to be A square root 2, so that would just be 1 square root 2. Now it doesn't matter which of the 45 degrees that you refer to, I'll just refer to this one at the bottom. So sine is going to be opposite over hypotenuse, so that would be 1 over square root 2. Now I'm going to give you the rationalized form of this, which is square root 2 over 2, because as we go through other sections and we continue to use these values, you'll be seeing both of these forms, so you need to be familiar with both of them. Okay, going back to this 45, cosine would be adjacent over hypotenuse, so same value. So 1 over square root 2, again, which would be square root 2 over 2. And then tangent would be opposite over adjacent, so 1 over 1 would just be 1. Now, for the 0 degrees, this is going to go back to something that we learned earlier. Actually going to go back to your coordinate system, this being your x and your y axis. Of course, the location of 0 degrees is here. So if you were to pick a point on the terminal side, of course there's numerous points you could choose, but again I'm going to keep it simple and just say that we're going to go a distance of 1, so that would be the point 1, 0. So x would be equal to 1, y would be equal to 0, and now what about r? If you remember, r is the distance from the origin to the point. So if that's the point 1, 0, the distance from the origin to that point would have to be 1. So we're just going to go back and think of sine, cosine, and tangent as just in terms of x, y, and r. Okay, so sine, if you remember, is y over r. So 0 over 1 would be 0. Cosine is x over r, so that would be 1 over 1, which is 1. And tangent is y over x, so 0 over 1 would just be 0. All right, now filling in 90 degrees basically the same way. Of course, 90 degrees, this being our x and our y axis. Of course, like if you were to draw it in standard position, you know, from here to here would be your 90 degrees. So again, we're going to pick a point that's on the terminal side. So I'm going to use the point 0, 1. So that means that x is equal to 0, y is equal to 1. So just like a while ago, if this is point 0, 1, r is the distance from the origin to that point, that distance would have to be 1. Okay, so sine is going to be y over r, so that would be 1 over 1, which is 1. And then cosine is going to be x over r, so that would be 0 over 1, which is 0. And then tangent is going to be y over x, so 1 over 0. Of course, 1 over 0 is undefined. Okay. So we're going to use these values that we've just determined on several of these problems that we're fixing to work. So you just need to keep that handy to refer to as we go through these examples. All right, so the first set of problems that we're going to look at, again, my instructions are off here just a little bit, but I'll scoot it over. Simplify each of the following by first substituting values from the table of exact values. So we're going to use the numbers that we've just come up with to work these out. Okay, with this first example, the 3 being in front of your sign, that's just multiplication. This means that you're going to take your value and square it. It's just to the second power. So first of all, you need to look up sine 30 degrees. So if you look back at your table, sine 30 degrees is 1/2. So you would have 3 times 1/2 squared. So this means to take your value and square it. Okay, now just use order of operation. So this would be 3 times 1/4, and of course 3 times 1/4 is 3/4. So there's your answer to that one. This is just getting you used to using your values as the purpose of these problems. All right, second problem. Okay, now here you've got parentheses, so all of this is going to be raised to the second power. You are not allowed to square these two things individually. That's because of the addition sign here. You need to get your value for sine 60, get your value for tangent 0, add, and then we'll do the squaring last. So going back to your table, you'll notice that sine 60 degrees is square root 3 over 2. Tangent of 0 degrees is 0. Of course, the addition here is real easy since you're just adding 0. So you do your addition, you get square root 3 over 2. And take this and square it, so that's going to give us 3/4 again. So there's your answer for that one. All right, the third one here. Okay, now this time your trig functions are individually squared. But first of all, look up cosine 45. Now, I gave you 2 different values there for cosine of 45 degrees. It actually doesn't matter which one you use. I'll just use the 1 over square root 2. So you would have 1 over square root 2 squared minus, and then look up cosine of 60 degrees, which is 1/2. So then that would be 1/2 squared. All right, now we need to square our fractions here before we can do the subtraction. So this is going to give us 1/2 minus 1/4. Of course, 1/2 minus 1/4 is 1/4. So there's your answer to that one. Okay, the next set of examples is very similar to what we were just doing, just a a little bit of difference here. So again, let's read through the instructions. For each expression that follows, let x equal 30 degrees, y equal 45 degrees, z equal 60 degrees, and then simplify. So first thing we're going to need to do is rewrite the problem by substituting the correct degree measurement in for the correct variable. So on this first one, we have 4 times cosine y. So going back in the instructions, I had told you that y was going to be 45 degrees. So 4 cosine 45 degrees. Now at this point, it's the same thing that we were doing just a few minutes ago. So look up cosine 45. Again, there's 2 different values there. It doesn't matter which one you use. I'll just use the other one this time, and I'll use square root 2 over 2. So now if you multiply, of course you can do your cross reducing here with your 4 and your 2, if you would like to do that, and once you multiply, you just end up with 2 square root 2. Alright, the next one, we have 2 times sine of 90 degrees minus z. Now I told you to let z equal 60 degrees, so we have 2 times sine of 90 degrees minus 60 degrees. Now you're going to have to do this subtraction first. You can't do like the distributive property and do sine 90 minus sine 60. Can't do that with your angle. So do your subtraction. So you'd have 2 times sine 30 degrees. Now look up your sine 30 degrees, which is 1/2. So 2 times 1/2, and your answer is 1. Okay, next. These problems are just testing you on your reciprocals, identities that we had learned earlier. It wants you to find the exact value for each of the following. Now you'll notice in both these examples, the 2 trig functions that I've given you were not in that table. But if you know sine, cosine, tangent, then you can use that information then to get cosecant or secant or cotangent. So what you're going to do here is actually look up, and I'm just going to put it in parentheses, you're going to look up sine 30 degrees because sine is the reciprocal of cosecant. So sine 30 degrees is 1/2, so your answer to this would just be the reciprocal since sine and cosecant are reciprocals to each other, therefore your answer is just 2. Okay, the second one here is cotangent 60 degrees. So again, I'll just write what we're going to look up on our table. We're going to look up tangent 60 degrees, which is square root 3. And since cotangent and tangent are reciprocals of each other, this would just be 1 over square root 3. So that's all that you would have to do to those problems.